I want to kind of get an introduction, right? An introduction. This is going to take us a couple days to get through, and then we'll spend next week playing craps. Probability. I've got a probability quiz up for you guys for Wednesday. Oh yeah, 3 coins and 3 dice. Who else needs coins? Got coins, okay. So,
I turned that in today.
that's okay. You can totally understand it today if you did it for today. I have them due on Wednesday. Yeah, you by all means you can turn it early if you want to. So what I want to do is I want to explore something. Can we see this? Okay, on the screen. Ish. Yeah. I want to explore. When you flip a coin, I want to know. I want to make sure we understand what does 50-50 mean. I want to make sure we understand what that means. What 50-50 implies. What 50-50 implies. Because you guys did that project last week, which I don't have for you yet. Amber's still grading them. I'm sure I'll get them back to you by Wednesday.
Well, 50-50 means you have 50% chance that it's going to land on head, or 1 in 2 chance.
I like. Did you hear what? There's a 50% chance, Frankie said, it's going to land on heads, or a 1 in 2 chance. Love that. Love it. And I interrupted you. I'm sorry.
No,
and same as tails.
Yeah.
Okay, same as tails. Good. Mel, go. What are you going to say?
That's what I.
You're going to say that. So 50-50 means, depending on how you want to think about it, I heard one vote for it means if you flip a coin, you've got a 50% chance of heads or tails. Another way of looking at 50% is also just 1 in 2, 1/2. That's 50% as a decimal. 1/2 or 0.5 if you want. If you like decimals better. I said decimal and fraction. 1/2 is a fraction. Tom.
I think that more as with enough trials, you will end up with 50%.
Now that is a second. I like this. Now we have 2 different definitions. So Tom says with enough trials. Finish that statement again. With enough trials,
You'll end up with 50% heads and 50% tails.
you'll get 50% heads
Or 1.
or 1/2. Good.
1/2. 0.5.
And 50% tails. What I would like everybody to do right now is I want to try to draw a distinction between these 2. These are actually 2 different definitions of what 50% probability means. Rob's saying, yeah, we see that, right? This one here is what a lot of textbooks will call a classical definition of probability. And this one down here is more of like what's called an empirical definition of probability. I want to kind of sketch those out, and then we're going to use the coins to find out what's going on. The classical definition, this classical, and I know we can't see this yet. This classical definition, let's swing this guy over. Yeah. What that tells us to do is, if we want to find the probability of heads, and I'm going to write that in a more compact way. Sometimes, and especially if you guys are taking 243, you'll see this quite a bit. A lot of times, instead of writing out the word probability of, we'll just put a P, and then whatever you're interested in parentheses. The thing you put in parentheses is often called an event. An event is something you're interested in. Let's make some definitions here. So this right here is probability of. And this right here is called an event. And an event is just it's a formal term. You can probably forget it if you want to. If you want to talk about it longhand, if you will. All it says is you're interested in something. And my first question was, what does it mean to have a 50-50 chance of heads? Now, technically speaking, it's not a 50-50 chance, it's 50-50 odds. I'm going to mention those briefly later on. I don't talk about odds. I think I told you guys too much in this class, and there's reasons for that. So, in order to get the probability of heads, you'd have to establish a ratio. Now, we've done this for years mentally when you flip coins, because we use coins to decide everything from football games to who takes the trash out. I used it to decide which trail I was going to take out in the woods. I went skating down at Meisner on early Saturday morning. Holy crap, beautiful. Nobody was out there at all, and I got to this one trail. I'm like, where can I go? I'm like, I'll flip a coin. And I realized I can't do it because I'm random. Pull the iPhone out, flip the coin with the iPhone. Left trail, beautiful. So glad I went that way. So the idea is you set up a ratio. And in the ratio, you have a numerator and denominator. Now for the coins, it's 1 and 2. We know that. 1 out of 2. And the reason it's 1 out of 2 is because the numerator is the number of items in what's called the event space. Don't worry about that right now. We'll come back to that. And the denominator is the number of items in what's called the sample space. And this might ring a bell from your last project. That might ring a bell from your last project. That's what you guys were actually constructing in your last project, for sample spaces. I know, thrilling. No.
I'm sorry.
It's quite all right. Let it out. Don't hide them. Let them out.
I need more oxygen.
That's okay. I think that's what a yawn is, right?
So they're very healthy.
So a sample space, essentially, what it does is it enumerates all the possible results of an experiment. And what the event space does is it picks those results of the experiment. It picks those results of the experiment that result in what you're interested in. So the event space, if you will, is like a successful trial. I'm interested in getting heads. How many ways can I actually get heads? I'm interested in a number of ways my experiment can happen. That's your sample space. But here's the kicker. That's so beautiful and simple, isn't it? I mean, you guys essentially said that. So what's the problem with it? Well, here's the problem with it. We bought 4 baby chicks yesterday to replace, well, not to replace, to augment our flock, because, you know, 4's not enough. The 4 we have are not laying eggs anymore. The 4 we're laying out. So they're old. I mean, they're adorable. We're still running around pooping and everything and fertilizing the lawn, which is great. But they're not laying eggs anymore. We got the chickens for the eggs. So I go to the store, and Max, go, here's a box. Go fill the box with, we'll analyze this in 243 more. And he picked a Sussex, he picked a Molten Java, which is a pretty cool name.
Yeah, it is.
A White Leghorn, and what was the other one he picked? Sussex, some other cute one.
Yeah.
Wasn't a Banny. No, it wasn't a Banny. Oh, damn it. It doesn't matter. Picked 4 of them. And once again, I asked the exact same question. I said, so, how do you know they're girls? Because they're sold as pullets, and a pullet is a female chick, by definition. A pullet, I think cockerel is a male chick. They're all pullets, you know, the Sussex pullets and Molten Java pullets. He's like, oh, he sexed them. Okay, how do you sex them? And there's a very, I got the whole 411 on how you sex a chicken. Does not sound easy. And I said, yeah, but you gotta be wrong sometimes, right? Like every once in a while, I've heard my neighbors get roosters. I mean, we bought our first 4 chicks, we got all girls. But you gotta be wrong sometimes. Like, oh yeah, absolutely. So I said, okay, so how often are you wrong? Because what I was thinking was, I was going in and flipping a coin and deciding what I was getting, boys or girls. But that would be terrible if you were going in to buy girls. Because if it were flipping a coin to decide on the gender of what you got, that means half of every chicken sold at the store would be roosters, and half would be pullets. And this is why I think I told you this, my wife wanted to bring home the chicks from Lava Ridge. I don't know if I told you this or not. Lava Ridge is going to raise chicks from eggs. They're going to get fertilized eggs and raise them and incubate them and have them. So like, let's just get our chicks from them this year. I'm like, no! If we bring home four chicks from Lava Ridge that way, on average, we're going to get 2 boys and 2 girls. I don't want roosters. I mean, I don't want roosters because my neighbors don't want them, A. B, they don't lay eggs. They're going to kick my ass if I walk out there. And C, I don't get eggs. I said that once already, didn't I? And I had 4 fingers up for C. Whatever. You can see how excited I am about the thought of getting roosters. So the thing about this is, this would be the same as the probability of getting a chicken from Lava Ridge. But this is not the same as getting a chicken from the feed stores. Anybody know what the probability is of getting a female chicken from the feed store is? It's 90%. This was the figure quoted to me by the guy at the desk.
Because of the sexting.
The sexing is only 90% accurate. So if they say something is a pullet, if they say it's female, they're right 9 times out of 10. Now, that is a coin flip. That is a coin flip. It's just not a coin like the one you have in front of you. I say it's a coin flip because when Max grabs that little cheap, peeping, chirping thing and puts it in the box, it's either a what? It's a boy or a girl, it's a male or a female. So it is a coin flip in that respect, in that it's either a boy or it's a girl. But it's not the same probability of being a boy versus being a girl. So that's why this argument works great for coin flips and pretty crappy for everything else. This makes a huge assumption, and the assumption is this. That was a long-winded way of explaining this. When you do your sample space, this assumes these items are equally likely. If you can't assume, or if you can't conclude that the outcomes are equally likely, you can't use that classical definition. The problem with the classical definition is it basically falls apart unless you're talking about coins or dice or cards. That's it. If you're talking about life insurance rates, buying chickens at the store, none of it works. None of it works. You have to use what's called an empirical definition. So I want to come back to this. I want to leave it up there. It's important. I'm not saying it's not important. I'm not saying it's not important. I'm saying it's fairly limited in where you can use it. You can use it. Vegas loves this. This is how Vegas keeps its lights on all the time, because it knows this really, really well. But the reason they can keep their lights on all the time, additionally, is because of the other definition, which is called the empirical definition, which, Tom, you actually were hinting at over here. The empirical definition. Yeah, and this is wicked cool. This is the way statistics is actually done almost all the time currently. And we're going to do it today off of your data that you have in front of you. You don't realize you have data yet. Your data you have in front of you, number one, and also with computer simulations, which is where this is where most of probability is done nowadays. This, if you're interested in the probability of heads, for example, if you're interested in the probability of what heads is, suppose you've never held a coin before. It's a strange round thing in my head. Why is it used for making decisions? So what you do is you start flipping it. You flip it. So what you do is you run a few trials. Tom, how did you define that? How did you say it earlier? You said, with enough trials. Few. Run enough trials. Run a bunch of trials. Run infinitely many trials. Don't worry about what enough looks like. We'll get into enough in 243 and 244. Enough. We'll get into enough. So what you do is you run a bunch of trials and you keep track. I put a blue cartridge in, it's starting to change over. I like that. You keep track of heads and tails. You keep track of your heads and tails. And if you're interested in what the chance of heads is, what would you then do? What do you think? It would still be a fraction. What would be in the fraction, though? How many times you flip? Where would that go? In the bottom! Number of trials. Thank you, Janelle's perfect. Number of trials goes in the bottom. What goes in the top?
The number of times it hits.
Yes! That is what's called Monte Carlo simulation. Not to be confused with Monty Hall from Wednesday of last week, although Monty Hall was a Monte Carlo simulation. Did you catch how we did both of these with Monty Hall? We did this first, because I asked you guys, I said, what should you do? Should you switch or should you stay? Nobody had an answer. Actually, you had three different answers. Some of you said we should switch, some of you said we should stay, and some of you said it didn't matter. Three awesome answers. We then proceeded to play the game like a couple hundred times. And then we had Excel simulate a few thousand times. And then we saw some cool results, didn't we? We said, oh crap, it looks like we should switch. Because when you switch, you win twice as much as when you don't switch. And then we broke it down to the classical definition because we could. There were actually only 9 outcomes in the entire experiment. You picked row number 1, the prize is behind row number 1. You picked row number 1, the prize is behind row number 2. You picked row number 1, the prize is behind row number 3. You picked row number 2, the prize is behind row number 1. I mean, there's only 9 outcomes, we could actually list them all out. But again, The reason that it falls beautifully into that classical definition, quite simply, is because of that limited tiny sample size. Most things don't, like the weather. Anybody look at the weather report today? I didn't either. Anybody see it? What is it? What is it today, Catherine?
It was supposedly like sunny and 41 degrees.
Sunny at 41, did they assign a percentage to it, like a 20% chance of sun or anything like that?
I didn't look.
Oh, you know what? Yeah, let's check it. Weather in Bend. Let's just see what we got here.
It was sprinkling all over.
It was! It was windy as hell, too. Usually that crazy wind comes in. Let's do a little weather here. Weather, Bend.
Mine says it's 45 now, but we have a 40% chance of rain in the next 10 minutes.
And then, does that just say 10 minutes?
No.
That's a good Bend forecast. Tornado at 3. Tsunami at 5.
50% chance of rain at 12.
50% chance of rain at 12. What the hell does that mean, 50%? Does that mean Bob Shaw has got a quarter in his pocket? He pulls it out, and it's got a little R and S for rain and sun.
Pretty much.
No, it doesn't, does it? What is that 40% chance? Does that mean, what does 40% chance mean? Does that mean he has a coin in his pocket that flips heads 40% of the time and tails 60% of the time? Because that's what it would have to mean if it was weighted that way, right? But that's not what it means. What it means is this. It means that over time, they have watched a whole bunch of different measures based on the weather. Give me one thing they monitor when they're talking about weather.
Clouds.
Clouds. Cloud cover, in particular, right? Yeah, how many of you guys have heard lenticular clouds around the sisters mean weather's coming? You ever seen those bagel-shaped clouds around the sisters? When you see those, get ready for some weather. It's coming somewhere. It's coming somewhere. Cloud cover. What else? Barometric pressure. Give me something else.
Humidity.
Humidity. Moisture. Yes, humidity and moisture. Good. Something else. Pretty obvious one. Temperature itself. Temperature itself. Prevailing winds. Prevailing winds. In Bend, I've learned this, that predominantly, fairly year-round, the winds start coming out of the southwest in the morning and they shift to the north, coming out of the northwest in the afternoon. I was pissed when I decided to live on the northeast side of town, because that means I have a headwind no matter where I'm going to or from work. I've got a headwind, which is great. What they do is they monitor all these things and probably some other stuff I don't understand. And they've noticed that in 40% of cases, when the data looks like it does right now, it has rained. That's what they're doing. They're not doing this. They can't do this. You can't say, what's the chance of their barometric pressure being whatever the hell it is right now? You can't say that, but you can track it. You can track it and run trials. This is wicked, wicked, wicked powerful. And the good news is that this does agree with that on the few cases you can actually use that. Now, the reason that's good isn't for weather, because weather doesn't have one of those classical breakdowns. It's got an empirical breakdown. It's basically all weather reporting is. Weather reporting has gotten better over the years by virtue of the fact that we have more data to actually look at. Our estimates have gotten more refined. But what has happened over the years, too, is that we've given away that for weather. But Vegas, for example, Vegas has both this and this. And they compare them constantly. There are people whose job it is in casinos just to watch the machines. Just to watch the machines and make sure they're behaving like they should. So they're watching this and making sure that is equal to that. How often do they change dice and cards at Vegas? It's every few games, I think, right? They're constantly taking cards, drilling holes through them and throwing them away, putting new cards in. Why? We don't want any edge to be given to the players.
Plus, they put 3 or 4 decks of cards in.
Do they still do that?
Yep.
They still do that. I thought, who's read Bringing Down the House? The book Bringing Down the House? Who's seen the movie 21? Okay, that's the book that movie was based on. A few of you have seen it. I heard, now maybe it was wrong, and I think it was in that book, those kids, they actually stopped Vegas from using 6-deck blackjack horseshoes. I could be wrong, and I think I read it in that book. They used to put 6 decks together to make a big horseshoe for playing blackjack, but because those kids cracked the system, they cracked the betting system, they made a bunch of kids from MIT. It's a great book if you haven't got a chance to read it. It's a fantastic book.
21.
21. The movie's great. The book, I think the book's even a little tiny bit better because they blow through the math so quickly in the movie.
Yeah.
Oh, the Monty Hall problem was in that movie too. They actually did the Monty Hall problem that we did in class on Wednesday was actually in that movie. But the book blows the math down. They were able to keep track of the. I'm not going to say too much about it because I want you to read it if you get a chance. If you did a book over spring break, it's a fantastic read. Just a little tiny bit of mathematics, it made them so much money. which is totally
Yeah,
rad.
they paid all their tuition, then they were
And then
breaking
some.
in and
Yep.
living the high.
And then some. The only thing they had to do was not get caught.
What's the book called?
It's called Bringing Down the House. I used to have a copy in my office, somebody walked off with it. So, it's unfortunate. Although that person, I'm sure, is very happy. I think your bookstore has it. At least it did a few years ago. There was a copy in the bookstore. I'm sure the library has a copy of it upstairs.
The bookstore won't let you buy books unless you require them for your class.
Yeah.
Really?
Yeah, they
New
changed
protocol thing.
No, I know this book wasn't in there for a class. Was there a section of books in there that are just like leisure books? Not anymore?
No.
It's a freaking crime. Go upstairs and borrow from the library. Even better. I'm sure there's a copy up there. If there isn't, I'll see to it that it was put in. Fantastic book. And the idea, though, is this matches that. So what I want to do right now, leading us up to break, is let's match that. We got about, however, flip one coin 10 times. Flip one coin 10 times and keep track of what you get. One coin 10 times, keep track of what you get. Okay?